today we'll be able to, or next week we'll be able to see the full class size. Now, I'm just going to share with you what we're going to do today. Today, for the first hour, we want to go through probability. For the rest of the class, I said, Jolene, we went through probability, but I want to refresh our memory. Now, the second hour, right, I've taken into the suggestion, or rather the opinions of Stella, and her school is starting on prelims revision already. So I was thinking that probably we can do in line with that, because I want you all not only to be very good in your Sec 4 topics, but also your Sec 1 to Sec 3. And for some of y'all who is not too good with your Sec 1 and Sec 3, right, I want to get you all up to speed. Sounds fair, right? Okay, then we slowly work up our ways towards our, of course, we will deal with WA2 first, followed by our plate. Okay, come. Everybody, right now, you all just have to look at the screen. There are three principles in which we will employ for our probability. So just look at the screen for a while. If you want to take out a paper, sure, go ahead, but not necessary. Okay, so I just need you to understand the concept of probability, which is, where is it? Here. Okay, come. Have I gone through this last week? No, right? No. Okay, now, so this one is a refresher for everybody. Now, probability is the number of favorable outcomes over the total possible outcomes. So now, this is the very, very basic of what we had learned for finding probabilities, right? So the previous time when we did this, right, we were going through different sets of numbers, and what I shared with the class is that if anybody can guess the correct number, right, I'll get them something. However, when the class choose, right, different options are. So there is a total of only one good option, which will give us a prize over the whole set of different outcomes. So in this case, there's a total of 100 different outcomes, but only one outcome will be rewarding. Okay, so in this case, the probability of winning at that point of time was the bubble T over here was 1/100. Okay, so that's the idea of our probability. Probability never exceeds 1. Okay, now, the first concept, right, when we are dealing with probability is this. Now, I share with the class this. When I wake up, I'll do either three things. I will either eat, brush my teeth, or shower. By the way, this is known as a tree diagram. Okay, tree diagram over here. Because from here, you will realize that it can branch out into different options. So this is our tree diagram over here. So now, when I wake up, I'll do either three things: eat, brush teeth, or shower. Now, if I have different probabilities, so let's say, for example, if the probability that I'll eat is 3 out of 10, so out of 10 times, 3 times I will go and eat. Brushing my teeth, out of 10 times, I will brush my teeth twice, which when I say it right now, not so hygienic, but if I ask the class, what is the probability that I'll shower? What will you tell me? Immediately. 5 out of 10, thank you very much. So what Elena say, right, is that this portion over here becomes 5 out of 10 because when we add all this probability up, this will be equals to 1 over here. Okay, so now our first learning lesson is this. Probability always adds up to 1. If you got an answer that is 1.5, 1.3, 1.1, even 1.05, that means it's wrong already. Okay, so maximum probability you should get is 1. And more often than not, you won't touch 1. Okay, you have 0 point something. Okay, that's lesson number 1. Now, the second lesson that we have done is this thing called additional probability. So what I mean by this, the question is asked, what is the probability that I'll eat or shower? So when we are using this kind of language or, so Stella, when I'm using the word or, right, what should tell me mathematically, what should I do with the ratios? Is it should I times, should I add, or what should I do with the probabilities? If I say I want to find the probability that I'll eat or shower, is it a plus, times, a minus, a divide? Times, okay, this one is plus. Okay, so every time when we are dealing with the language or, we are trying to plus. So I want to find the probability that I'll eat or I'll shower. So I'll eat or I'll shower over here. That means 3 out of 10 plus 5 out of 10 over here. Okay, so every time we're dealing with additional probability, or when they are using the words or over here, or means to say that you will always equate it with a plus. You're adding the probabilities together. So 3 out of 10 plus 5 out of 10 equals to 8 out of 10. Okay, which obviously you're going to simplify to 4 over 5. Now, that is lesson number 2. Now, the final lesson over here is about this thing called our events that happens one after another. So now, let's say, for example, if I'm in a car and I'm at a junction over here. So this is my car over here. Okay, I'm at a junction. And at this junction, I can go left, I can go straight, I can turn right over here. Now, the probability that I will do so, respectively, is 3 out of 10, 2 out of 10, and 5 out of 10. Now, after I take a left, there's another junction over here. So in this junction, I can do either three things: turn left, go straight, or go right over here. So questions are always ask you, what is the probability that I'll go left and I'll go left again? So the language that we're using is and. So if I was to ask Elena, if they use the word and, should I plus, times, divide, or minus? Plus, okay, times this one. So in this case, probability that I'll go left and I'll go left over here is a multiplication. So that means to say left multiply by left over here. So it's a event that happens one after another. So let me just summarize whatever we have learned for these three concepts of probability. Number one, probability always adds up to be 1. Anything more than that, that means you have gone off course already. Number two, additional probability. When they use the word or, means to say I'm doing a plus. Okay. Lastly, when they say they want to find a probability of something and something, we are doing multiplication. So these are the three key concepts. If you apply them, you should be all good. Okay, so far? Okay, come. Now, can we all go to... Should I do something simpler? Okay, come. Can we all turn to page 32 over here? I don't remember us doing questions as such. Okay, page 32 over here. You don't even need a foolscap paper. You just have to do on the paper itself. Okay. Okay, page 32. So this. Okay, are we all there? Okay, now. For Jolene's information, this is a tree diagram. The reason why this looks like is called a tree diagram is because there is branches, and in these branches, right, you can branch off from the bigger branch. So it's like a tree diagram. Okay. So by the way, if you see it this way, okay, this is like a tree. I do not know whether you can see. A sideways tree. Okay, looks like a tree. Here's tree diagram over here. Now, a packet contains a number of identical flower seeds. Half of the seeds produce red flowers. 1/5 produce white flowers, and the remaining 6 produce. This is not tallow. This one is yellow. Okay, so this in this case, put yellow over here. Okay, yellow flowers. 2 seeds are planted. Now, concept number one. Jolene, what is our first concept that we have learned for our probability? Probability adds up to be? Thank you very much. So in this case, I have different kinds of seeds. Red flowering seeds, white flowering seeds, and yellow flowering seeds. So if I was to ask you, Jolene, over here, this, and this one will add up into 1, right? So what is this value over here? What should I be doing? How do I find this value over here? Minus what? What minus what? Yes, thank you very much. So I have 1 minus 1/2 divide minus 1/5 over here. In this case, I should get somebody punch the calculator. What do you have? And you have these numbers that are in this operation. 1 minus half minus 1/5. Okay, somebody shout out the answer, please. Thank you very much. 3/10. Okay, in this case, this one will be 3/10. Okay, so I can just simply write here 3/10. Okay, now, can I ask the class, yeah, do you have calculator, right? Who don't have calculator? Yeah, only one. Okay, just give me a while. Give me a short while. Just let me fetch the calculator. Okay, come. let's carry on with our question over here. Now, if I was to ask the class, class, how many total seats, red seats do I have, white seats and yellow seats? What will you tell me? Convert to 10 over here. Thank you very much. So this young man says that, hey, we convert it to 10. So, but wait a minute. Wait a minute. Why are we converting to 10? Why not 20? Why not 40? Why not 50? Good question, right? So over here, right, Xingen is saying that I'm asking the class, hey, how many red, white, and yellow seats do I have? He say convert the base to 10 over here. But then, which is sensible, but then may I ask, why not 20? Why not 40 over here? Because 20 out of 40 will still give me half, correct? And then let's say, for example, if I have 8 over 40, this will also give me 1 over 5. So why not 40? Why not 20? Why 10? Smallest common one. Not exactly. What do you think? His 10 is correct, by the way. But why 10? Why not 20? There must be some relationship. By the way, you don't have to go far. It's somewhere in the diagram. The answer is somewhere in the diagram. You just have to look at the diagram. Because, thank you very much. You see, the next tree diagram over here, the denominator is 9. So that means to say I must be starting out with 10, right? Because if I start out with 10, right, the next number, because I pick one seed, so the denominator becomes 9. So that's why this one must be 10. Thank you very much. So in this case, can I get everybody to convert it? Just right to the side over here. If this is base 10, base 10, denominator 10, this one will be 5 over 10, and this one will be 2 over 10. Does it make sense to everybody? Okay, so now I'm just gonna color all of this. This is 5 red. Okay, for those who are not so familiar with probability, I have 1 red, 2, 3, 4, and 5. I have 2 white. In this case, I'll use white as this color. I have 2, and then my last one is yellow, right? I have 3 of them. So 1, 2. I know it's orange lah, but anyway, something along those lines. So now, can I ask Electra, over here, right? I have a total of 5 red seeds, right? Now, if I want to pick another red seed, so this one is my second pick. Second pick over here. This is my first pick. So if I pick a red seed, what is the probability that I'll pick another red seed? Thank you very much. This one is 4 over 9. So in this case, we write 4, 9 over here. Okay, Irfan, I want to find this probability over here. What is this probability? So my first pick is a red seed. I want to find out what's the probability of picking a yellow seed over here, or rather yellow flowering seed. What will you tell me? Sorry, 3 over? Yes, thank you very much. This one is 3 over 9. Okay, so Jolene, are you catching on the pattern? Yes, no? Yeah, I'm not too sure. Okay, so still somewhere around there. Now, next question I have is for Jing En. Jing En, my first pick now is a white. So if I pick a white flowering seed, I want to find the probability of a red one. So what will you tell me? 5 over 9, yes, because I have 1, 2, 3, 4, 5. And then I have a total of 9 of them. So in this case, this one will be 5 over 9. And then Elena, what do I have for my white one over here? If I pick a white, and I want to pick another white one over here. So what's the probability? Yes, thank you very much. 1 over 9. Okay, 1 over 9. Okay, my last one is for our dear Jolene. So Jolene, let me just go and shift this downwards here. Okay, now, Jolene, you're going to help me with this. If I pick a yellow flowering seed over here, so this is my first pick. Okay, this is my first pick over here. And I want to pick another yellow flowering seed. What will you tell me? Over? Yes, thank you very much. Okay, so it will be 2 over 9 over here. Okay. So now, you realize that there's a couple of things that can make sure that you get the correct numbers. Number one thing is this. this value plus this value plus this value must be equals to 1 over here. Okay, that is one way to check whether your answer is correct. Okay, the second way is to go and draw this thing over here. So when you draw all these, right, you can see what are the number of remaining seeds that we have accordingly. Okay, so two different ways to go and check your answer. Now, first one over here, question B. Find as a fraction in its simplest form the probability that both seeds will produce a yellow flower. So that means to say, listen to the language, both seeds will produce a yellow flower. So I want to see a presentation. Probability that it's a yellow and a yellow. So Irfan, when we are using the word and, what is it a times, plus, minus, divide? Times, right? Okay. So over here, my first one is 3 out of 10. The probability I'll pick a first yellow flower is 3 out of 10. N means multiply. This one will be 2 over 9. Okay, so simple enough. This one 3 remainder 10 times 2 remainder 9. Everybody can punch in your calculator. Give me the answer. What do you get for this one? 1 out of 15. Thank you very much. Okay, 1 out of 15 over here. Okay, so nice and easy. Yellow and yellow. Okay, so let me just put here. N means you need to go and multiply. If you use the word or, means you plus. That's the only two things. Concept 2, concept 3 over here. Okay. Okay, now this one, part 2, neither seeds will produce a red flower. So I open this question for the class. Class, if the question asks you to find a probability that neither seeds will produce a red flower, how should I do this? Red flower, 1 minus probability that is a red flower, But I pick 2 seeds. I have 2 seeds, so first seed is, so 1 minus probability that is a red and red. How about yellow and red? Then on the other side, also included, right? Yeah, so a lot of combination. So no go. What is your option? Same is same also. Okay, so let's go and understand now. Jingwen and Stella have this idea that if we take 1, which is the total probability, minus the probability of what you say, red and red, right? Then after that, I have red. This one is all, don't copy this, red and yellow. Then we have red and white, is it? But then I also have white and yellow, and then white and red. It's very long, too many already. I don't do this way. Any other shorter way? 1 minus is correct. 1 minus something, or there is a way to do it. You can do it this way for sure, but is there a shorter way to do it? Because like that you waste your time, right? So wait, just let me ask the class, class, how many different kinds of seeds do I have? 3, right? Okay, I have red, I have white, I have yellow. So if I don't want to pick a red flowering seed, so that means I'm picking what? I'll read the question. So I have 3 categories. Okay, over here, I have 3 categories of flowering seeds, right? I have the red one, I have the white one, I have the yellow one, correct? All right. If I don't want to pick a red one, means to say I'm picking what? Yeah, white and yellow. So how many white and yellow do I have? How many white and yellow do I have? 5 out of 10, right? So in this case, if I don't want any seeds, that is over here, I don't want any red a seed that produce a red flower. Can we agree? I want to find a probability of that is not red, followed by not red again also, right? Okay, so not red. So if I just now the class give me, the first pick, when it is not a red seed, it will be 5 out of 10. Correct? Okay. So now, can I ask the class, if my second pick, I want to pick a seed that is not red, What will you tell me? Okay, so I zooming back here again. I have 10 different seats, correct? I don't want to pick these red seats. How many seats do I have? 5 or 10, right? Okay, let's say, for example, I pick a yellow one. So how many seats do I have that is not red? Yes, thank you very much. 4 out of 9. So this one is n, means I need 2 times a plus. Thank you very much. This one times 4 over 9. Okay, equals to, someone give me the answer. What do we have for this one? 2 over 9. Thank you very much. This one will be 2 over 9. Okay, now I pause here first. Are we okay? Or you all don't understand what I'm talking about? Okay. Can Yes, please go ahead. Now, last one over here. A third seed is planted. Find the probability that the 2 flowers, there's 2 flowers and 1 red flower is produced. So that means to say, I want to pick a yellow one, then another yellow one, and then after that, red one over here. So I have 3 different kinds of picks, right? So now, let's get Irfan to help us. Irfan, don't worry, you will be guided. I want to find a probability that I pick a yellow, and then another yellow, and then another red one over here. Okay, so the language is red and yellow and red over here. Okay, so now Irfan, you're going to share with us what is the probability that I'll pick a yellow seed at the first onset? Okay, very good. So this one is 3 over 10. Now, if I pick another, I want to pick another yellow seed, what will you tell me? 9. Okay, times 2 over 9, very good. Multiply by 2 over 9. And then my last one over here, if I pick a yellow, and now I want to pick a red over here, what will you tell me? Times 5. 5 over? 10. 10 I already picked one. I pick another one. I want to pick this one. What's the probability? 4 over 9. 4 over 9? Sir, how many red I have? 1, 2, 3, 4, 5. I have 5 red seeds, right? So what's the denominator? How many? 5 out of how many? How many is this one? 5 out of 8. Yes, thank you very much. 5 out of 8. Okay, now I pause here first. This is still incomplete. Why? Didn't the question say, Teacher Wilson, the question say a third seed is planted, find the probability that it is 2 yellow and 1 red, That yellow, red, what? So how come Teacher Wilson said it's incomplete? Thank you very much, my dear boy. There are different combinations. Now, my first combi is this. Yellow, and red. My second combination is yellow, red, and yellow. Correct, right? It's still 2 yellow flowers and 1 red one. And my last one over here, Elena, what is the combination? Electra, what is the combination? If first one is yellow, red, second one is yellow, red, yellow, last one is? Thank you very much. This one is red, yellow, and yellow over here. So in this case, this is where you start copying. This one over here, I have to go and multiply by 3 because I have 1 combination, 2 combination, and 3 combination over here. Okay, so everybody go and punch in your calculator. Let's match our answer with Irfan's answer. Okay, everybody punch in. Irfan, please let us know what is your result for question C. 1 over 8. 1 over 8. Do we all get 1 over 8? There's no 1 over 8. Okay, come. This one is 1 over 8. Okay, now, Jolene, are you able to kind of grasp the concept of a tree diagram? Okay, can Okay, now, let's continue with this one over here. Let me just go and erase all of this. Okay, now let's go and read this question. It is given that a box contains 13 apples and 15 peaches. Two fruits are selected from the box at random. If an apple is selected, it is replaced. Okay, come, everybody go and highlight this part over here. When an apple is selected, it is replaced. That means to say if I take the apple, I put it back again. But when a peach is selected, it is not replaced. Okay, so if I pick a peach, I don't put back into this box over here. Okay, so this one is the important criteria for this question. Now, complete the tree diagram and show the probabilities of the outcomes are. So again, if you're not familiar with this, can I just go and draw 13 apples and then 15 peach? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then for my peach over here, I duplicate. Can I change color? Color, this one. And then I add 2 more. This one and this one over here. Okay. So these are my 13 apples and 15. Now, the question says if I pick an apple over here, so let me just put here, I will replace. So I will replace my apple. Okay, I will replace it. Now, if I pick an apple over here, and then I want to pick another apple, so but I put back another apple. Okay, so can I ask Elena, what would that probability be? Okay, so right now I pick an apple, right? So the probability of picking an apple is 13 out of 28, correct? So I put 1 here, pick 1. But then I will replace another apple. So what is the probability that I can pick another apple in my next pick? This is my second pick over here. No, not too sure, huh? Jing'an? Yes, 13 over 28, right? So this one will be 13 over 28. Because if I take 1 apple, I replace this apple, I still have 13 apples, correct? How about 28? Okay. Now, same question, but for Electra. If I pick an apple first, I replace this apple, what's the probability that I'll pick a peach? Fifteen over 28. Yes, thank you very much. This one will be 15 over 28. Okay, now, next one over here. Let's have Irfan to help us. So Irfan, right now when I pick a peach, so this one will not replace. I will not replace this peach over here. Okay, so if I pick a peach, what is the probability that I'll pick an apple? Everybody's sneezing already. Okay, Irfan, I repeat. How many peaches do I have at the start? How many fruits do I have altogether? Yeah, right? Okay, come. Now, my first pick over here is a peach, correct? Now, if I pick a peach, I don't replace the peach, right? What is the probability that I will pick an apple in my next pick? 27, yes, 13 over 27. So this one will be 13 over 27. Okay, now Stella, finish it for us. This one over here, what do I have? Yes, thank you very much. This one will be 14 over 27 over here. Okay, so these are all my probabilities. Okay, now my first question over here, B part 1. I want to find the probability that both fruits selected are the same. So can I ask, in this case, I want to ask Jolene. Jolene, what is the combination? I don't need to ask you to give me the exact. What is the combination? Both fruits selected are the same. Means what? Yeah, this one. What are the combinations of it? Both fruits are selected are the same, right? Means what? What does this mean? Times Ooh, means what? Is it apple and peach? Can it be apple and peach? No, right? Then it should be what? N? Or it should be. Yes, thank you very much. So in this case, can we agree? We want to find a probability that is an apple and then another apple, or this one is a peach and a peach over here. Okay, so just sorry, this one is peach and peach over here. So Jing'en, what is that probability that I'll take an apple and an apple? Okay, 13 over 28 times 13 over 28. So all means I need to do what? Apple, apple, or peach and peach means what? Plus, and then the peach is? Yes, 15 over 28 times 14 over 27 over here. Okay, so in this case, can everybody punch in your calculators? It's going to be a very, very big number, but please don't be afraid of it. Somebody shout out once you get the results. Sorry? 5 over 9, no. It's not going to be 5 over 9. 3481 over 7056. Absolutely correct. Okay. So why are we doing this question? Is because sometimes our probability can go until very, very big. So students are very scared. Hey, I do this one, I might get maybe it's the wrong answer. No, sometimes the probability are that big. Okay. Now, part 2, at least one of the fruits is peach. Okay, at least one of the fruits is a peach. So when we are dealing with at least, Stella, what should we be doing for at least? 1. Yes, 1 minus the probability of something over here. Okay, so now I want you to be very, very careful. Every time when you see at least, it's always 1 minus the probability of something. So now let me ask Elena, if I want to find that at least one of the fruits is peach, means I take 1 minus the probability of what? Apple and? Yes, thank you very much. This one is apple and apple over here. Okay, because if I take away that probability, I will have peach and peach, peach and apple, apple and peach over here. Okay, so 1 minus this entire thing. So 1 minus apple and apple is 13 over 28 square, right? Because times by itself. So everybody, punch in your calculator. Let's match your answers with mine. 13 over 28. Okay, can we agree? We get this 615 over 784 over here. Correct? Okay, okay, good. Now, these are the 2 questions to warm up the whole class. Any questions that you want to clarify at this juncture? Any questions that you want to clarify at this point? Straightforward enough? Okay, now, let's go and do some solid exercises over here. Can I confirm we have not done this? Okay, okay, come. Everybody, let's take a look at question 1. Okay, this one you need to take foolscap paper. Do you all have foolscap paper? Please take out a foolscap paper. If you don't have, okay, pass around. You have? No? Okay, then after that, pass to Stella. Okay, everybody, take out your foolscap paper over here. Okay, come. Let's take a look at this question. Question number 1 over here. A bag contains 5 red balls and 4 blue balls over here. So I have 1, 2, 3, 4, 5. 5 red ones and 4 blue. 1, 2, 3, 4 over here. Now, that means to say I have a total of how many? Total of 9. Thank you very much. So that means 9 will be my denominator. Now, in a game, a player draws a ball from back at random, one after another without replacement. Go and highlight this one, one without replacement. Okay, that means if I take one, I don't replace already. I just take it and put it somewhere. Okay, the player has to draw two balls of the same color consecutively to win. Okay, Irfan, what does it mean by same color consecutively? Means what? Can I take a red and a blue then win? Can Sir. All right. Okay. What does same color consecutive means? Yes, red, or I can take a blue to win. Now, by drawing a tree diagram, calculate the probability that the player wins only on the third draw. Okay, the draw over here. Now, let's start this very, very simply. I have, okay, let me just use black. I think I use black better. I have red. This is red over here. And then I also have blue. This one is blue. Now, the probability, by the way, if you do not already know, this is my first draw. Okay, I draw it the first time. So I have two different options, right? Either a red or blue one over here. Jolene, give me the probabilities of picking a red and picking a blue over here. What will you tell me? Okay, 5/9 for my red, and then my blue will be? Yes, 4/9. Thank you very much. Okay, so the probabilities, I'll pick a red and then a blue over here. Now, if I can only win on the third draw, right? That means in this case, let me just go and branch it out. This is my second pick. Sorry. Okay, this one is red. And this one is blue over here. Okay, so let me just duplicate this. Right, so this over here, this part over here, this is my second draw. Correct? Second draw over here. First draw is this one. Second draw is as such. Correct? Now, if I want to win by the third draw means what? Can I win? Can I have red? Cannot. That means my first one must be a red, blue, then blue, right? Or it could be blue, then what? Red. Okay, so the winning conditions is this. So in order to win, okay, in order to win by the third draw, that means to say my first one must be a red, followed by a blue, or it must be a blue, then red over here. Okay, so this is the only combination that I will win by the third draw. Any other combination means I'll win. Red, I win already. Blue, I win. But this one is the second draw. Red, blue, red, blue, and blue. Blue, red, and blue also don't win anything. So the only winning condition is red, blue, or blue, red over here. Okay, now let's get Jing En. Fill us with all this information over here. What are the probabilities of picking a red after I pick a red? So what is this probability over here? 4/8. Okay, very good. Irfan, this one? If I pick a red, what's the probability I'll pick a blue here? 4/8. Yes, so in this case, this one will be 4/8. Jolene, in this case, right, if I pick a blue, now I want to find the probability of picking a red. What will you tell me? If I pick a blue. 5/? Yes, 5/8. So this one should be 5/8, which means to say, Elena, what is this probability over here if I pick a blue? 3/8. Thank you very much. This one will be 3/8. Now, am I interested to go and do a branch here? Am I interested in doing a branch over here? Because the thing, you see, I branch out, right? Then after that, from my red, I branch out over here. Am I interested to branch out here? Does it make sense? Yes, or no? Yes, no, doesn't make sense. Because if I have a red, I means I win already, what? So I don't care. So I'm interested in red, blue, and then I branch out and I have another blue over here. So I'm not interested in this part. So this part over here, I am not interested in branching out. Okay. Now the next part over here I want to branch out is this part. Okay, because this one will give me my red, and this one is my blue over here. So now let's get something more difficult for Stella. Stella, this is, by the way, this one is my third pick, right? So let me just put here. This is my third draw. Okay, this one is my third draw over here. Okay, so Stella, give us the probabilities for these two. What is the probability when I pick a red, then a blue? Now I want to find a red again. Okay. Yes, 4 out of 7 and 3 out of 7. So now what Stella did, right, was that she found out this probability and then she just take 1 minus 4 over 7, which is 3 over 7. Okay. Now, second question for the class. Am I interested to branch out here? Yes or no? No, because blue means I win already, so I don't care about this part. So in this case, I don't care about this part. Now, the part that I care of will be this part. Okay, so I ran out of space. So it should look something like that. By the way, you're just trying to navigate some space over here. This one should be my red, and then my blue. Okay, let me get Jing'en to help me with this one. Jing'en, I pick a blue for my first pick. Second pick, I pick a red over here. What is the probability I'll pick a red again? Thank you very much. 4 over 7. Okay, 4 over 7. And the blue one will be? Thank you very much. So is 3 over 7. Okay, this is your tree diagram. Make sure that you know how to draw it. Okay, this part I know space so I will keep definitely I will overlap with the one on top. Okay, now, so this is my tree diagram. I need to calculate the probability that the player wins only on a third draw. So if that's the case, let's go and get Electra to help us. Electra, since you have given us this combination, what is the probability that I'll get a red, and then a blue and blue, or this one is a blue or red, or sorry, and red over here? Give me the numbers. Yes, so 5 over 9 times 4 over 8 times 3 over 7. Then, yes, 4 over 9 times 5 over 8 times 4 over 7. Okay, everybody go and punch in your calculator. I will also do this calculation with you all. Let's see whether we have the same answer for this. Okay, please go and punch in your calculator. 9 times 14. Okay, go and punch it in, please. Thank you very much. Okay, write your answers down. I will tell you what I got for you. Okay, you should be getting 5 over 18. Okay, you got 5 over 18, give yourself a tick because you punched incorrectly in your calculator. Okay, 5 over 18 over here. Okay, are we good? Can understand the concept? Okay, so now it's your time to go and try on the question on for size. Can I just get everybody to go and try question 2, 3, 4, and 5? This is own time, own target. Please go and try question 2, 3, 4, and 5. Okay, let's go. If you need help, if you need help, please go and sound out. If not, I think that you're all doing well. Okay, come. Yes. All the green okay. Same both of you at the same problem. Okay. Now, over here, this one is your green disk question. So let me just go and shift it to the other side. Just give me a short while. Yeah. Okay, so green disk, you all managed to find it, right? So the number of green disks that I have is equals to 38, right? There's a total of 38 green disks. Okay, so if I remove away X amount, means I plus minus times divide square root minus, right? So 38 minus X, this will be removing X amount, correct? How many total disks do I have? If I remove X amount, will it affect the 60? Yes. So it will be 60 minus, yeah. And then this one will becomes 9 over 20. So this one is 9 over 20. So Jing En, Irfan, what should I do when I get this sort of thing? Part of equation. What's the method? Start with C one. CM. Hey, huh? What is CM? Not Crystal Maiden, eh? What is CM? Cross? Now you know cross multiply. So in this case, this one will be 38 minus x equals to 9. 60 minus x over here. So I expand it out. If my math is correct, I should have 76. 760 minus 20x equals to 540 minus 9x. 11x, and if I'm not wrong, this is 220. Okay, so x is equals to 220 divided by 11, which is equals to 22. 20. Yes. Okay, so my question 2B is with you. Okay, come everybody, let's take a 5 minutes break. We already passed the hour mark. So take a 5 minutes break. You all can continue if you want to, but take a 5 minutes break, and then after that, when we are done with the break, then we'll come back and do our questions. Okay? Okay, please continue on with your other questions over here. Now, question 3, I think some of you have done it, but you have to be very, very careful. Over here, I'm just going to do one very small part for you. Question 3 over here, number 1 is asking you find the number of red discs, number of the value of R, right? Because R is the number of red discs over here. So in this case, it's very simple. This one is, there are 6 blue discs, probably a setting of blue discs is this. So probability that I have a blue is 2/5. Now I have a total of 6 blue discs, so I want to change my numerator to 6. So that's why this one over here I have to multiply by 3. Bottom also I have to multiply by 3. So this one should be 15 over here. Okay, so there is a total of 15 discs in the back. My red disc, okay, this one is my R over here, is 15 minus 6, which is 9 discs. Okay. Now, this one I think you all managed to get it lah, so no issues. Now, the problem, or rather the pitfall of this question is that question B, they ask you to go and draw a tree diagram. Now, this part is the tricky part because, okay, because over here, we have red, this is red, and then we have a blue disc, right? Now, can I just ask the class, this one is simple question, why is it wrong to put it like that? Why wrong? I'm not saying wrong, but why if I put like that very dangerous? Huh? What? Huh? Not like the value, very good. So this one is the simplified value of it. But then if you go and minus, if you go and expand it out to the next part over here, I will have red and blue, right? So some students, this is the pitfall. I don't copy this part, this one is the wrong part. If I pick like that, 3 and 2/5, some students will say, oh, then this one must be 2/4 and this one is 2/4. Not correct, this is not the correct way to do it. Now, if you want to find a correct way, you have to go and write out the original value, which is over here, the number of red discs is 9 out of 15, and this is 6 out of 15. If I pick another red, this one should be 8/14, followed by this one, which is 6/14 over here. Okay, so this is the correct way. You have to be very, very careful. Okay. So this one, I just shift it down here so that you all can better see it. This one is red and blue over here. So this one is 8/, this one should be 9. 9/14. And this one over here should be 5/14. Okay, so question 3B, I already give you the first 2 answers. Now your last one is just go and find this one by yourself. Okay, question 4. Okay, wait, I'll come to you over there. Hey, come. How can I help you? Okay, now I ask you all, I give you all 2. Probably that I read is done. Probably that I know is done. When I add together, equal 1. And looking at the part of it. So it's showing 1. So I have read, I have read, I know that the probability that I want. So I use it. Okay. Yeah, let's say typically reads one edge and uses another edge, but the second one is A does not use both methods, so does not use it. You will read, then I, and I. You use from the probability you go and pick the one with the same. You change it to all to the same. Okay, so I have win, lose, and tie. Now, what is your question? You seem like lost on the jungle already. From how open? What we doing, sir? Good. So let me ask you the thing. If I play against this team, but if I play 15 matches, if I count -1 and -1 goal, that means the last game when I no chance of winning. So you always be a win. So that means the win will still be 8 out of 50, lose will still be this 5. Then you also you block, then you go on. You can't move me. I want to steal your attention. Are we all at question 4? Yes, are we all at question 4? Now, there are two things in which I want to share with the class. One is from the question itself. Second one is by Elena's question. So let me just go and crop this over here. Now, this one you have to read between the lines. Number one thing, the probability that I win is equals to 8 out of 15, correct? Probability that I lose is equals to 1/3, which I change to 15 will be 5 out of 15. Now, you might have overheard my conversation. This plus this is only equals to 13 out of 15, right? So there is another component which we have to read between the lines, which means to say that the probability that I will tie, or some of you all say draw, this one should be 2 out of 15. Now, there was a very, very good question that was asked by Elena. Elena said, or rather, it was from Electra. Electra said, hey, teacher, so if I have this tree diagram over here, win, lose, or I tie over here, if I go into the next part, right, will my probability change? So win, lose, and tie. So this one will be 8 out of 15, 5 out of 15, and 2 out of 15. So what I told Electra is that no, the probability won't change. Because if I play another 8 more matches, right, does that mean that my probability against team B is 0 winning? Cannot be right. So this is a with replacement question. With replacement question. So this one will still be 8 out of 15, 5 out of 15, and 2 out of 15 over here. Now, the second question that was asked by Elena was this. Sure. How do we know that it is with replacement? Okay, so there are a couple of conditions. Number one, okay, is when you are doing with matches. So like team A versus team B, like the matches over here. In this case, this is a with replacement question. Number two, when you have a huge population over here. So it could be people in a city. So the question say, oh, the probability of picking a person in town A or city A that has blood type O is this. This is a huge population. Or they can say, or the number of cars in the road. Okay, this one is cars on the road over here. Okay, cars on the road. They say that, the cars, 8 out of 5 of the cars will turn left. 5 out of 15 of the cars will go straight. Only 2 out of 15 of the cars will turn right. So when you're dealing with huge population, the question is always with replacement. Okay, so two different, very, very good questions. One is this match will always be the same probability. Second, the different scenarios in which this will be with replacement. Is that okay? Non-direction. You mean, let's say, for example, cars on the road, right? In this case, if the car will turn left, turn right, the probability still remains. Because I have so many cars, how many cars are you talking about? But if they say specific amount, let's say, for example, if it's a limited amount, like I have 13 apples or 15 peaches, all these amounts quite small, right? So in this case, I can do a without replacement. So I can take one and put. But there's so many cars on the road. All of them will most probably turn left or straight or right? So because when I'm dealing with a huge population, I don't care about the denominator. There's so many of it. Right? Does it make sense for you? No. Okay, let's say, for example, the probability that only, let's say I have 1, 2, 3, 4, 5, 2, 4, 6. Okay, so let's say, for example, only one person in the class will pass. So the probability is 1. But if I'm looking at the whole of Singapore, so in this case, my denominator is so big. So if that's the case, my probability doesn't change. So the probability that, let's say, for example, people in Singapore will pass O level or N level, 1 out of 6. So if I pick another person, right, that probability is 1 out. But in our class over here, it's so small. If I'm talking about small population, then probability will pass 1 out of 6. Then the next one will be something like that. Okay, yeah. Okay, carry on, everybody. Please go and carry on with until question 5. Okay, I just need you to do until question number 5. Now, so okay, that means team A does not lose anyway to team B. So what's the best scenario? Then you win again, right? So we win, that's the one scenario. Can I win then I draw? Still win, right? But I can try the first time and then I win the second. Win. Because the fact is, I do not lose. It means the form out I draw the team, then the next one. Yes. So what are the form around again? Lose, not lose, do not lose, you tell me lose. First one, team A wins one match and then lose. Okay, so let's win, lose, or okay. That's the first one. Second one. Yeah. Win, tie, win. Yes. Very good. Four scenarios. Okay, continue. Is which one? Question for B. Win, tie, win, tie. I don't lose, but it's tie win. Yeah, the tie win. How much chicken wing you apply and then I will. Okay, Irfan. Sir, you waiting for my answer, sir? Okay, Jolie. Jolie, try. How can I help you in time? I am sorry again. Hai à? Yes sir. Bien, bien nào. Nhớ lên tu đi sir. Nhớ lên tu đi sir. Một tuần. Right. Part one. Yes. Okay, good. If I pick one and more, I'm not involved. Because I'm not one and I'm not one and more. Pick one and more. Let's go. Yeah, okay, come. Movie. Oh, movie. Yes. Okay. Okay, very good. Nine. So many. Hello. Yes. Very full house. Okay, can 26. I will use the one of them. Yes. Yes. Very good. Mhm. Okay, two more. Still you can breathe when you don't want to use. You have a place in your breathe, you know. But the place in your where you need was a 2 meters. So my first we never we so we one okay. So can we the first make the name of the higher what else? Five first and then being there and the last number. Yeah, okay. Okay. Yeah. Zero, zero, yeah, yeah, zero. All right. Okay, now, you need how we right, you have to go. Okay, come. Another 2 more minutes. Try to finish up the question. Looking around. What is it that you need help with, sir? Let me know. Okay, come, everybody. Have fun trying to finish up. Later, I'll just send this to you. Okay, come, everybody. Let me grab your attention over here. Now, what I am seeing so far from our probability is that we are somewhere there, but not there yet. Okay, so I'm gonna do this with you. Okay, this one over here, 6, 7, 8, 9. 6, 7, 8, 9 over here. This one will be homework. However, I'm going to give you a chance. I'm going to give you a chance. Let's play a game to see whether you all do homework. Okay, sounds fair? Sounds fair. Okay, now, have you heard before of this thing called the game show host theory? Have you heard before? Never. Okay, now let's go and play this game show host theory. Let me see, where is it now? Okay, not this one. This one is stats over here. Where is my probability? Joe Tomate. Okay, this one. Okay, never heard before of this called the game show host problem or game show host theory. Monty Hall problem. Never heard before? This never heard before. Never. Okay, come. Now, whenever you're last time when we all still watching TV, right? There's always this game show, right? At the end of the game show, there will be one lucky contestant over here, and then the game show say, okay, now behind these 3 doors, one door will be a sports car, the other 2 doors will be a goods over here. You all more or less have some ideas on like Wheel of Fortune or whatever it is, right? Something along this line. Now, this is the game show host theory. Now, right now the host will say that there are 2 goods and 1 sports car over here. However, because the door are closed, we do not know where the car or the goods are. Okay, we do not know, right? Okay. Now, if I ask the class, class, what is the probability that we will get a sports car? What will you tell me? 1/3, which is 33.33333%, right? Very, very, very good. Okay, that's fantastic. So let's say, for example, I pick Jing En. Let's say if I pick Jing En to be our contestant over here, and Jing En say, okay, Teacher Wilson, I want to pick door number 1 as my door to open to win the sports car over here. So just now, Electra said that we have 33.3% or 1/3 probability to win the sports car, correct? Okay, so suppose you chose door number 1. The game show host then opens door number 3 and show you that it's a good. Is it in your interest to change your decision? So let's say, for example, okay, Jing En picks door number 1. Then the game show, okay, you pick number 1, I open door number 3 over here. This is a good. Then after the game show host say, hey, Jing En, is it your interest to go and switch to door number 2, or do you want to stick to door number 1? What will you say? Stick to door number 1. How about you? What will you do if you're a contestant? Will you stick to door number 1 or go to door number 2? Will you change or stick? Change to door number 2. What about you? Stick. Door 2. Okay. Door 2. How about you? Stay. Okay. Some people stay, some people change because they stay because they believe that, hey, this is our winning door over here. Some people say, okay, since you open, maybe door number 2 might be it. Okay. Some people have different choice. Okay. Now, if you have stayed with your decision, the probability of you winning the car is 33.3%. This is what Electra said, right? 1/3 over here. Now, however, if you switch the door, okay, however you switch the door, they have a total of 66.7% of winning sports car. Then after that, some of students say, hey, sure, isn't it still the same probability? What? 1/3, 1/3, 1/3, Okay, now, this one is not true because this one is a variable change. So what I mean by this, okay, one door will have 1/3, correct? Second door over here also have a probability of 1/3. Third door over here will have 1/3. So the total of 1 over here, right? So if you stick to door number 1, you will only have 33.3% of winning. Now, because they already opened this door over here, these two add up together will be 2/3, the probability of winning. But he opened already. So that means there is a 2/3% of your, or 2/3 probability of you winning the sports car if switch your car. So this is known as the game show host theory or the game show host problem. So it's always in your interest to go and switch door, okay, because you have a higher percentage of winning this sports car. Okay, now this is something that you might learn in the future when it comes to probability. I want to play a game with you all. Okay, now among you all, who wants to play this game? Just one person. This person will decide for us whether we will do question 6, 7, 8, and 9 over here. Anybody want to try to play this game or not? This is the game show host problem. By the way, I already have picked the doors and stuff like that. So what I'm trying to say is that there are 3 doors. There are 3 doors over here. 2 doors will have homework. 1 door no homework. So anybody want to play? Okay, let's pick Electra. Okay, let's get Electra to help us with this. So Electra, you will decide for the whole class whether we will do homework or not. Okay, so I tell you the theory. So it's your option to change. If you want to stick to door, whatever, is up to you. Okay, but there's a certain probability of it. Okay, so now we close the door. Close the door. All the homework, not homework, all jump out already. All jump out. Okay, now let me ask Electra this question. Please choose a door. Are you gonna choose door number 1, door number 2, or door number 3? 1, 2, or 3. Okay, door number 2. You okay? Everybody okay with door number 2? Are we gonna confirm the decision, door number 2? Yes. Okay, confirm. Okay. Now this one is already preset. I already preset this thing. Okay. So door number 2. Okay. Over here, If student chooses door number 2, let's go and see. Okay, teacher opens door number 1. Okay, now this is your page. I open. Hey, there is a homework door open already. So now my question to you is this, Electra. Do you want to switch door or do you want to stick to door number 2 over here? Everybody's homework lies on you. So everybody, you want to stick to door number 2 or you want to change? Variable change. Stick or change? Do you want to stick to door number 2 or do you want to change? Change? Stick? Electron, please give me your answer. Are you going to stick to door number 2 or are you going to switch to door number 3? Stick to door number 2. The rest of y'all okay, Stick with door number 2. Stick with door number 2. But just now you see the variable change. No, okay, I still want to stick that. Confirm, Okay, you change, change to door number 3. Yeah, so let's go and see, So now you change from door number 2 to door number 3 over here. Confirm or not? Confirm. Everybody confirm, door number 3. Okay, door number 3. Let's see whether you all will do homework. So switch or stay. You are going to switch to door number 3. Are we ready? Okay, no. Okay, so this is your variable change over here. Okay, so today no homework, but before you all close things up, there are 3 different concepts that we learned today. Concept number 1, what is our first concept we have learned? Irfan. Irfan, you always look at me like a blank, like I'm talking nonsense. What is my first concept for our probability over here? Probability always add up to? Okay, very good. Second concept that we have learned. If it's the word, when we use the word or. Plus, or means plus. Jolene, when the word is and means what? Times. Okay, so these are the 3 concepts. Okay, so no homework for today. Very, very lucky. Okay, that's it. Thank you very much, everybody. Please have a good rest back at home. Okay.